Hello, and thanks for clicking on this next Prenarculus production. Today, we're going to talk about how to graph logarithmic functions, an exciting event. So let's get started. Okay, so what we've already talked about so far is we've talked about how to graph an exponential function, right? So we know how to graph the equation y equals 2 to the x. And if you look at our graph to the right here, this is the graph of y equals 2 to the x here in red. Okay, there is a horizontal asymptote here at y equals 0, right, that goes across the x-axis that this graph will not cross. Okay, now one of the other things that we already know is that a logarithmic function is the inverse of an exponential function. So for example, if we have our equation y equals 2 to the x, that's an exponential function. And then we have an equation of log of x with base 2. We know how to take this log equation that we have here, and we know how to switch its form, right? We can switch it into exponential form. So if we were to do that, we would get 2 to the y equals x. And now what you can see is if you look at the graphs that we've already made back in the other section, y equals 2 to the x, and you look at this equation that we just put into exponential form, and we compare them, the difference between the two is that the x and the y have been switched, right? And we know that already because we already know that exponential and log functions are inverses of each other. And what does it mean to be an inverse function? It means you switch the x and the y value. Okay? So now the question is, what does the graph of y equals log of x with base 2 look like? Well, we could figure it out, okay, pretty easily. But before we do, let's actually take a look at y equals 2 to the x, which we already know how to graph. So if you remember, we found our key points on y equals 2 to the x. We have 3 key points, and then we have a horizontal asymptote at y equals 0. So our key points, we plugged in x equals -1, x equals 0, and x equals 1, and we're looking for the y value. So 2 to the -1 is 1/2, 2 to the 0 is 1, 2 to the 1 is 2. Okay, those are our key points on y equals 2 to the x, and you can see them, they are graphed over here. Okay, keep in mind that every 2 boxes is 1 unit, right? So this is the point 0, 1. Okay, and then we have the point over here, 1, 2. There it is. Okay, 1, 2 is on there, and also the point -1, 1/2 is also on there. So if you go -1, 1/2, remember, keep in mind each box is only a half a unit on this graph, so that's why if I want to go over to -1, I'm going over 2 boxes, right? Each box is only a half a unit. Okay, so those are our 3 key points there, and then our horizontal asymptote at y equals 0. Okay, so that's all well and good, but I don't want to graph y equals 2 to the x. I want to graph y equals log of x with base 2, which we converted to exponential form, and we know it's 2 to the y equals x. But we also know that the log function and the exponential functions are inverses of each other. So we should be able to switch the x and the y. So if we want to graph y equals log of x with base 2, or 2 to the y equals x, the key points on that are going to be a little bit different because normally we would always plug in a number for x and get an answer for y. But if we're to use this equation that we have here, 2 to the y equals x, we're going to have to plug in numbers for y, and that will actually give us answers for x. So if I plug -1 in for y to this equation, 2 to the -1 is 1/2. If I plug in 0, 2 to the 0 is 1, but x is 1. And then if I plug in 1, 2 to the 1 is 2, but x is equal to 2. Okay? And now, if you look at my key points between the 2 graphs, y equals 2 to the x and 2 to the y equals x, they are inverses of each other. The x and the y values have been switched. okay, on every one of my key points. That's because the exponential and the log functions are inverses of each other. We switch the x and the y values. Well, that also means that the horizontal asymptote at y equals 0 would have to be switched. So instead of y equals 0, the line x equals 0 is an asymptote. But x equals 0 is a vertical line. So there'll be a vertical asymptote at the line x equals 0 on the graph of y equals log of x with base 2. So we can see that here. The graph in blue is the graph of y equals log of x with base 2. And if you're going over a half, you're going down to -1. Remember, each box is a half a unit. We're going over to 1, and then 0, and then right 2, and up 1. That's this point. Here's 2, 1. Here's 1, 0. Here is 1/2, -1. And what happens is these two graphs are reflected over the line y equals x. They're symmetric. This is the line y equals x. And that should make sense because the difference between this exponential function and the log function is that the x and y are switched. Okay? So this graph in blue is symmetric to the graph that's in red across the line y equals x. That's what it means to be an inverse, for two functions to be inverses. They're symmetric about the line y equals x. All right, so let's go and see if we can make our own graph without knowing what the exponential function graph looks like. Okay, so let's give it a shot. All right, so let's try to graph y equals log of x with base 3. All right, so the first thing that I suggest you do is you switch the form on this, because you're not going to be able to do much with this in log form, but you can do a lot with it in exponential. So let's rewrite it. If we switch the form, we get 3 to the y is equal to x. Okay, so now we're going to find our key points on 3 to the y equals x. Now remember, it's kind of backward because we're plugging in values for y, -1, 0, and 1, and we're going to get answers for x. This is a log graph, so it will have a vertical asymptote at the line x equals 0. Okay? So if I plug in -1 for y, 3 to the -1, that's going to be 1/3. If I plug in 0 for y, 3 to the 0 is 1. If I plug in 1 for y, 3 to the 1 is 3. Okay, so let's graph these 3 points. So we're going to go right 1/3 and down 1. And then we're going to go right 0, or I'm sorry, right 1 up 0, and then right 3 up 1. There's a vertical asymptote at x equals 0. Let's draw that vertical line. And what you get is you get the graph of y equals log of x with base 3. This is the correct graph for this parent graph. This is a parent graph. Okay, there's no transformations on it or anything like that. We're going to talk about transformations in one moment. But this is a parent graph. And this would be the first thing that you'd look at to get your key points and start with your vertical asymptote for this graph at x equals 0. Okay, keep in mind that log graphs have vertical asymptotes. Exponential graphs have horizontal asymptotes. One of the most commonly made mistakes here when you're graphing these two. Okay, so let's take a look and see some transformations. So first thing I want you to do is to name the parent graph and then tell me the transformation. So for this first graph, the parent is y equals log of x. Now, if you remember, if there's no base on a log, it's base 10, right? It's understood to be base 10, okay? If you converted this to exponential form, you would get 10 to the y equals x. That's where you get your key points from, as well as your vertical asymptote starting at x equals 0. But I'm interested right now in the transformations. So there are two. This negative here is a reflection in the x-axis. Okay, it takes the y's and multiplies them by -1. And then the +2 that's in here with the x moves the graph left 2. Takes the x's and subtracts 2. So if you're going to transform your graph, you'd have to take the x's, subtract 2, take the y's and multiply them by -1. And that would get you your new graph after you find the key points here. All right, so we're just talking about naming the parent and the transformations. For the next one, we have y equals 5 ln x plus 3. So the parent graph is y equals ln x. Now remember, ln is a fancy way to say log with base e, right? E is that number 2.718, okay, the natural log. So if I were to convert this to exponential form, I would have e to the y is equal to x. And after that, let's talk about the transformations. So the 5 is a vertical stretch by factor 5. I'm going to take the y's and multiply them by 5. And then the plus 3 takes you up 3. So again, notice the difference. So notice the difference between these two that are here. When I have the x plus 2, it's in parentheses. I'm moving the graph left 2. If I just write ln x with no parentheses and then add 3, I'm moving the graph up. Okay, so that's a key difference. All right. All right, and then we have one more here. We have y equals log of negative 4x plus 4 base 7. So the parent graph is y equals log of x base 7. If I convert it, it would be 7 to the y equals x. I can get my key points, and we'll practice this in a few minutes. Now, we do have to do a little bit more work to this one to find the transformations. We do have to factor out the negative 4. That is important. Take out the negative 4. You'll be left with x minus 1 in there. So now there are 3 transformations that are being done. Number 1, the negative is a reflection across the y-axis. So that means you're going to take the x's multiplying by negative 1. Number 2, the 4 is a horizontal stretch or shrink, depending on how you think about it. Okay, and then you're going to multiply the x's by 1/4. And finally, the minus 1 moves the graph right 1. So you're going to take the x's and add 1. So if you were going to transform these points, you would have to take the x's, multiply them by negative 1/4, and then add 1 to them. The y's would stay the same. Okay, so those are some examples of some parent graphs with some transformations. All right, thanks for clicking.